All right, let's start on this section. So we have three figures with a set of different number of toothpicks. So let's look at figure 1. How many toothpicks are there? 4. And then figure 2, how many toothpicks are there? 8. And then number 3? 12. So what's going on? How do you get to the next figure? Add 4, or let's look at this chart. So let's say the figure number is the input. So you have figure 1, figure 2, figure 3. And then our output is the number of toothpicks. So that's 4, 8, and 12. Then if you have n number of figures, what would you actually do to find out how many toothpicks there are? Yeah? N by 4. What do you mean by? Multiply. Okay, so let's say 4n. So the process is 4n. So basically, if you had an infinitely number of figures, you would just multiply that figure number by n. Okay, we're going to look at a few more of these kind of problems. But let's first do some vocab check. Okay, first, variable. What is a variable? It's kind of the same idea as in the English language, right? So variable means what? What do you guys think? Nick, you had an idea?
Like I was saying, kind of like the n in the last problem.
Right.
It's kind of like the unknown.
Yes. Yeah, the unknown. So we can say that it's like a symbol. Oops. A symbol. Ooh, sorry. So usually a letter to represent one or more numbers. So something like Nick said, like last one, like n, or we usually see x and so on. Then what is a constant?
Something that doesn't change.
Yeah, something that doesn't change. Yeah, so same thing as when we're saying something is constant. In life, that just means it never changes. So something like 3 or pi or some number, not a variable, which can be one or more numbers. Next, this is I know at this time you're probably not going to be confused, but I see this problem all the time. So what's the difference between expression and equation? Yes. Okay, which one has an equal sign?
Equation.
Yes. Equation has an equal sign because kind of the word equal is in here, right? So equation has an equal sign and expression does not have equal sign. Okay, and then both of them are mathematical phrases. So like a sentence that has numbers, operating symbols, or variables. Can someone give me an example of expression? X plus 2, perfect. And then what about equation? Yeah, very good. X plus 2 equals 5. Okay, so what happens is a lot of people see this, and you're like, and then I ask them, what does x equal to? And they would say -2. And I said, how do you know that? There's nothing equal to. How can you even solve for x? So it happens all the time. So please be careful. All right, let's look at this graph. This is a graph that shows the length of fishes that can be contained in different sized fish tanks. Can you figure out what the process column is? Okay, so let's look at this chart. So on the bottom is the combined fish lengths, and on the y-axis is the tank capacity that they suggest you have. So if you have no fish, what is the size you're supposed to buy? 0, but not according to this graph. They're like, if you want to prepare for having a fish, 2. How did you know? Yeah, look at the graph, right? So if you have no fish, which is 0, you have a size of 2 gallons. So you're kind of like preparing to buy these fishes. Okay, so first one, let's say fish length. And then capacity would be the output. So if you have 0, you should buy a 2-gallon tank just to prepare. If your fish length is 1 inch total, what is the capacity you're supposed to buy? 3. That's like I've never seen a fish that small. Okay, so if your fish length is 2, then capacity is 4. Okay, so then if your fish length is n, what's the capacity? N? N plus 2, very good. All right. So let's go ahead and do some practice. All right, so you are going to do 1 and 2. Let me check it, and then you can do 3. 3 is pretty tricky, so make sure you finish 1 and 2 first and show me before you do number 3. All right, number 3. This one's pretty hard. I am very surprised that a lot of you got it. It took me a while to figure out, but answer is 5n minus 1. And if you're like, how do I even do this? And you couldn't figure out a way to just do this systematically, chapter 9, we're going to do all this stuff. Okay, so let's go ahead and have you do this one. So look at that, that graph and answer 4, 5, 6. All right, I think this is where we ended last time, right? Not sure if you had a chance to do this yet, but if you didn't finish 4, 5, 6, go ahead and finish it right now, and then I'm going to check your answer. So raise your hand when you're done, and I will check it. Okay. All right, so what is the cost of purchasing 5 DVDs?
$80.
Good, $80. And then what about buying 10? $160. So then what is it buying n number?
16n.
16n. All right, pretty easy. Let's review numbers. Yeah, do you guys have a question? Okay. So let's review numbers a little bit. So we're going to go down to the smallest category of numbers, which is in natural numbers. Do you guys, can you guys give me an example of natural number? 1? Huh? 5? Okay, good. 14? What about 0? No, 0 doesn't count. What about -1? No. Okay, so natural numbers are counting numbers, so things you can count with, so 1, 2, 3, 4, 5, and we do not include 0. So no zeros. So that is the smallest category of numbers because it includes the smallest number or smallest amount of numbers. The next category up is whole numbers. So you can see how the family kind of works. Whole numbers will include natural numbers. So what's the difference between whole numbers and natural numbers? Huh? Oh no, but someone said it. Zeros. Yes, so you can include 0. So 0, 1, 5, 14. So those are all whole numbers. Okay, so the difference between whole numbers and natural numbers is that whole numbers has one more number, which is 0. So on here, on our categories, whole numbers are natural numbers and 0. Okay, so that is our next set of numbers. The next one up is integers. So integers are going to include whole numbers and natural numbers. So what is included now in integers that was not in whole numbers? Negatives. Okay, so we have all the numbers that we had before, and then we have the negative of them. So this is our family of numbers. So if you go down to integers, it's going to be all the whole numbers. The opposite, when we say opposite, we mean negative. And then just a reminder that 0 is also in here. So that's integers. Next one up, rational numbers. Rational numbers. Now we're getting to categories that's a little bit more specific. Rational numbers Can someone give me an example of rational numbers? Okay, 2.4, correct.
1/2.
1/2, that's correct. 5.57, okay, good. So let's look at what the characteristics are of rational numbers. Well, there is a very special word in the word rational that tells you what kind of number it is. Yeah?
Is it a number that has an n?
Yes, it is, but there's a special word inside the word rational. Ratio. Yes, ratio. What does ratio mean? Okay, for example, 2 to 1. That's a ratio, right? And we can also turn that into 2/1. So basically, ratio means fraction. So anything that can become a fraction is a rational number. So why is 2.4 a rational number? Or why is 2.4 something we can turn into fraction? What is it in fraction? 12/5? 12/5, yes. Oh, maybe this is too hard of a problem to do in your head. Okay, all right. Bad example, sorry about that. Okay, let's try another one. Let's say we have 0.3. Is 0.3 a rational number? Yes. Well, what is it in fraction?
3/10.
Yes, very good. 3/10. Now, what about this one? 0.33 repeating. Okay, how many people say no, not a rational number? How many people say yes, rational number? Okay, those who say yes, what is this in fraction?
3/9.
3/9 or reduced to 1/3, yes. So anything that can turn into a fraction is a rational number. Now, sometimes you may not know that it could become a fraction, so how are you going to tell? Well, if you are given a decimal, there are two ways to tell. First, if the decimal ends, it definitely can become a fraction. Okay, that's a given. If the decimal repeats, it will turn into a fraction. How? Next year, pre-calc, we'll learn how to change that into a fraction. But just know that if it repeats, it will become a fraction. All right, so let's write down here. Rational numbers. All numbers that you can write as a ratio or fraction. A number with a decimal, so if you have no idea if the decimal can be a fraction, then you check. Does it have a repeating decimal? Repeating means that it has a pattern. It just keeps repeating that pattern. Or it has a terminating decimal. Terminating means that it ends. So 2.1, 3.14, something that ends, that is a rational number. All right, on the other side, we have irrational numbers. What are some examples of irrational numbers? Okay, pi? You were going to say pi or something else? Huh? Very specific number. What? That's okay. What's another example of irrational number? 25/9, but we said any fraction is a rational number. So what's an irrational number? Another example. Only pi?
Square root 3.
Yes, square root 3. Are all square roots irrational? No. What's an example of a square root that's not irrational? Yeah?
Square root 25.
Okay, square root 25 is not irrational because equals 5. Yeah, 5 is what kind of number? Whole number or natural number or integer or? Yeah, very good. All right, and then so we have rational and irrational. So irrational numbers are going to be exactly the opposite of rational numbers. So they are always going to be decimals that do not terminate. So it goes on forever or repeat. So there is no pattern to it. So if you look at pi, 3.1415, was it 92? Wow. Yeah, so there's no pattern to the whole thing. It just keeps going on forever. All right. And both of these sets of numbers, you can see that rational has all these subsets in between, underneath it, and then irrational, both of them make up real numbers. So real numbers is just all the things in life we can actually work with. So that is our last one here that exists in real world. Real numbers are all the numbers that exist in the real world. Okay, let's look at our number line just to review. So this is our number line, and let's put some numbers in here. Okay, the first thing is I want you to graph 5 over 4. So where is 5 over 4? Go ahead and graph it. Okay, Lauren, where is 5 over 4?
Little after the 1.
Little after the 1. So 1.25 is the exact number of 5 over 4. Good. Next, let's have you graph square root 3. Can you guess where square root 3 is? If you don't have a calculator, try it. Does anyone know where square root 3 is? Well, what's square root 4?
2.
2. So is it bigger than 2 or smaller than 2? Smaller.
1.7.
It's like
Yeah.
right before the 2.
Yeah, right before 2, around 1.5. The exact number is about 1.7. So you want to kind of be able to guess where numbers should be. So 1.7 is where square root 3 is, right there. And then the last thing I want you to graph is negative pi. Negative pi. Where is negative pi? All right, Jeff looks like he's ready. Where's negative pi?
Like a tiny bit past the -3.
Correct. So, wrong color. So right here, a little bit past -3. All right, how do you write 5 is greater than -2? Yes, so 5 is greater than -2. What about x is less than or equal to 8? With a little, yeah. X is less than or equal to 8. Now let me ask you another question. Can you write it like this? Does it mean the same thing?
No. Yeah.
Yes, it means the same thing.
It's
It's just a different phrase.
Yeah, different phrase. Now it means the same thing, so mathematically it's fine, but it's a little bit awkward to look at. So I just say that x always starts a conversation, so always write x first. So you could write it that way. It's just very awkward trying to figure out what you're saying. So x first. All right, let's review some vocab. Reciprocal. Okay, let's look at reciprocal. What is the reciprocal of 3? Yeah? 1/3. Okay, so some of you might think it's -1/3. Now you're thinking opposite reciprocal. Reciprocal is simply 1 divided by that number. So reciprocal just means 1 divided by that number. So 3, the reciprocal of 3 is 1 over 3. What about 2/5? What is the reciprocal of 2/5? 5 over 2. Okay, just flip it. Okay, so the reciprocal is 5 over 2. What about opposite? What does opposite mean? Negative. Okay. Yeah, just negative. Negative of that number. So opposite just means negative of the number. All right, so let's go ahead and have you guys try 1, 2, 3. Let me know when you're done. Okay, let's start with Daniel. The reciprocal of each natural number is a natural number. True or false?
False.
False. Give me a supporting evidence.
1 over 4.
Okay, 4, and then reciprocal is
1 over
1 over 4. So 1 over 4 is not a natural number. Correct. Okay, Kendrick. All square roots are irrational numbers.
False.
False. Give me a counter example.
Square root 25.
Okay, square root 25 is 5, so 5 is not irrational. Good. All right, we already graphed square root 3, so that's about 1.7, so that's A. And then, Heller, where is -2 and 1/2?
-2 and 3.
Perfect. Okay. All right, any questions?